Thank you very much, everyone, for joining this evening. This is an AONM webinar, that's the Academy of Nutritional Medicine, on Kryptopyrroluria, KPU. And I'm Gilian Crowther, the Director of Research at AONM. And so I'll just share and then go to my slides, which I hopefully have ready here. So this is called sorry, I'll just say for 1 minute that I will talk for about 45 minutes, and then there'll be time for questions after that. And this will probably be part 1 of 2, because having run through it now a couple of times, it's become clear that there's so much to say about therapy that I don't think we can fit that in the 40 minutes. So we'll probably do a second part, and we'll announce the time for that, or the date, in a couple of days. So the mysteries of Kryptopyrroluria. Why is it a mystery? Well, there's not much that's been written about it in the English-speaking world, unfortunately, though there's a lot in German. And because I did spend much of my life in Germany and do speak German, I've looked at the literature in great detail, ordered in all the books that there are, read them, and so on. And so I hope to be shedding some light on it. I'll be talking today about the roles of pyrroles, porphyrins, and heme in KPU. I will abbreviate it KPU now, though of course that stands for this much longer word. I'll be talking about the symptoms, the testing, and then touching on the therapeutic approaches, which we'll cover more another time. So what does the word Kryptopyrroluria actually mean? And again, sorry if I didn't repeat. I think I said it just before 7. Please do put any questions or comments that you have in the chat or the Q&A, and I'll be opening up both afterwards. So crypto means hidden or invisible. Pyrrole means a chemical substance involved in the formation of heme, and urea means excreted in the urine. So this is really undetected, abnormally increased excretion of pyrroles in the urine. And different terms have been used over the years: KPU, HPU, pyrroluria. If you look it up on the internet, you may find it without that extra R, the mauve factor, and Malvaria. So it was discovered in the early 1960s when doctors whose names you've probably heard, Abraham Hoffer, Donald Irvin, and Carl C. Pfeiffer, were investigating the possible root cause of psychiatric illness. And in the urine of their psychiatric patients, they found a mauve factor, called mauve because of its color, on the chromatograms that were being used. And Dr. Pfeiffer found that many of them that had been labeled schizophrenic were actually suffering from an excess of this mauve factor in their urine, which he termed cryptopyrroles. And in pyrroluria, pyrroles bind with B6 and then with zinc, depleting these nutrients, and often others as well, especially manganese. And from the book Nutrition and Mental Illness, written by Carl Pfeiffer, there's the quotation: approximately 15 to 30% of schizophrenics, so-called, have pyrroluria. It can be inherited. That's primary KPU. So as therapists, it's worth watching for it in families. And the secondary form is acquired KPU. And stress, both psychological and physical, does increase it. It really accentuates it hugely. And some of the reasons for that will come up, I hope, in this talk. Therapists report finding it more commonly in women than in males. Some reports are 9 females to 1 male, and more commonly in children too. And Carl Pfeiffer, who discovered it, estimated that more than 10% of the population is affected by KPU. And because that was back in the 60s, you can imagine that It may be more now for the reasons that we'll be talking about. Dr. Klinghardt has always said that he finds a very high number of KPU sufferers in his Lyme patients, in this quotation from the excellent article in the Townsend letter called Kryptopyrroluria, a major piece of the puzzle in overcoming chronic Lyme disease. He said that he found the number of KPU sufferers in Lyme disease to be 80% or higher. In patients with heavy metal toxicity, over 75%, and in children with autism, over 80%. So these are very high numbers. And the laboratory explanation of what they find is that this chemical byproduct, which I won't attempt to pronounce, but you can see the designation of it there, is a byproduct of hemoglobin synthesis. And it's been found that circulating cryptopyrrole forms a base with the aldehyde form of vitamin B6 in the blood. And this combination then binds with zinc and builds an insoluble complex. And normally, bile is excreted via the stool and the pyrroles with it, because your red blood cells do need to turn over. But when the amounts are high, like in KPU, then they start being excreted in the urine. And this depletes the blood of B6, zinc, and often other nutrients as well. So what are pyrroles? To understand this, we first need to understand what porphyrins are. And they're a class of macrocycles comprised of 4 pyrrole units. And they have a characteristic purple color, and that's where the word porphyrin comes from the Greek porphyria, which means purple. And you can see here that heme consists of a porphyrin ring that holds a central iron ion. So this is the porphyrin, and it's composed of 4 pyrroles. I do spell heme here, by the way, in this presentation as H-E-M-E, but of course the British spelling would properly be H-A-E-M. That's because so many of the scientific articles that I'll be quoting from do use that spelling, H-E-M-E. So looking at pyrroles, they're really the scaffolding holding together these porphyrins. And they're defined as electron-rich molecules with a 5-membered ring that contains 1 nitrogen and 4 carbon atoms. So again, you can see examples of them here. More scientific literature here for those who'd like to read it. And of course, you will get the slides afterwards, as well as the recording. So don't worry if I don't go through these sometimes very text-heavy pages. Fascinatingly, the University of Cambridge has done a recent study where they found that the movement of pyrroles seems to defy classical physics, and that they seem to adhere more to quantum laws because they're so absolutely minuscule rather than sort of Newtonian physics. And so here you can see how heme is formed. This is heme with the iron in the center, the red one, and the green one is chlorophyll. And there's really no difference apart from magnesium at the center of chlorophyll. So the numbers in nature are absolutely extraordinary. You may think that there's 1 heme molecule perhaps in a red blood cell, but actually a typical red blood cell contains about 270 million hemoglobin molecules. Now, each carries 4 heme groups, and each of those heme groups has 4 pyrroles. So in just 1 red blood cell, one of these erythrocytes, you have over 4 billion pyrroles. So when the scaffolding is falling apart, which is basically what KPU means, that scaffolding isn't holding anymore and they're tumbling out of the body, we're talking about huge numbers here, tiny as they are. especially because we make 2 to 3 million red blood cells every second. So there are 4 key steps in the synthesis of heme that take place in the mitochondria. And the synthesis of, and this gets a little bit complicated here, but please bear with me. The synthesis of aminolevulinic acid is the first. And you can see that there are other steps as well inside the mitochondria. The green ones are inside the mitochondria. Ferrochelatase, this one here, and this one here. And aminolevulinic acid is B6 dependent. So you'll very quickly get a vicious cycle if this disruption of heme has begun, perhaps because one of these enzymes here is not working, and we'll talk about that more a bit later. But if one of them is not working, or you have, for some reason, the primary form that some sources on the web say is simply an overproduction of pyrroles, but in any case, you're not able to hold the heme together as you should, then you won't be producing enough B6 in your cells, and then you won't be able to produce aminolevulinic acid, because it's essential, as it says here, that it's catalyzed by B6 enzyme, the production from here, synthase to aminolevulinic acid. So you can see how that vicious cycle will easily start setting in. And the breakdown of heme synthesis can, of course, be due to a mitochondrial disorder. If you think about it, if the mitochondria are not working as they should, then you're not going to get the production of heme working properly either, because these 4 crucial steps take place inside the mitochondria. And it's important to remember that what this means is hypoxia, in other words, lack of oxygen. And that's not just in the blood, because obviously the blood is trying to deliver oxygen to the tissues and the organs. So that's also called ischemia. In other words, it will generally be in various parts of the body, perhaps depending on where your weaknesses are, but something that's very familiar to patients with ME, chronic fatigue, fibromyalgia, and so on. So the 4 of them here are now coming up with rings. And one thing of note is that over the last 4 years, we've had this extraordinary situation of SARS-CoV-2 ghosting around and causing havoc. And actually, the spike protein can also bind heme, as this article and many others explain. Heme binding to the SARS-CoV-2 spike glycoprotein. So COVID-19 is known to be associated with extensive hemolysis. The articles on that are rife. So the hemolytic anemia that can be caused by this is not necessarily just going to be resolved by giving patients iron, which is the sort of knee-jerk reaction. You may need to dig a lot deeper and find out why this anemia is happening. So the symptoms of KPU are extensive. Heme is vital for every mitochondrion. It's in cytochrome C, and from previous talks on the mitochondria, if you haven't seen them, please do look them up. It's a very, very complex little organelle, and we have hundreds of them in most cells, sometimes thousands. But each electron transport chain in the mitochondria has something called cytochrome C, and that transfers 1 electron at a time via its heme group from the 3rd complex of the electron transport chain to the 4th. And without heme, that's not going to work. So basically, that means that every cell in the body is going to have a problem potentially. Again, not all at once, of course. You know, the body is sensible and it tends to keep the absolutely essential organs and tissues going at the expense of others that it says it can spare, like sort of eyesight and hearing and so on, that again, chronic fatigue patients will know tend to be the first to go. in terms of just, having sensitivity issues in areas that take up a lot of ATP, because what you're losing is your ATP in the mitochondria. So this is the heme molecule that needs to be there so badly. And where we have heme in the body is actually in every single cell, because the mitochondria are in every cell except for the erythrocytes. And the erythrocytes, of course, are carrying heme in the hemoglobin. So there's no cell without the need for heme in the body. So I'll just take a minute to have a quick glass of water or juice. What is heme used for in the body? Well, in the bloodstream, we've talked about that very clearly, hemoglobin. In the mitochondria for cytochrome C. We mustn't forget that cytochrome C is vital for apoptosis. Therapists among you will know that P57 can only be activated to kill cancer cells if cytochrome C is working. So again, you have a vicious cycle. If your mitochondria have gone down because of lack of heme and cytochrome C isn't working, then you'll have a lot more difficulty killing the cancer cells in that particular part of the body. Cytochrome P450 detoxification enzymes all have heme at their center and cannot work without it. So every form of detoxification will be impaired. Enzymes such as the very important antioxidant enzyme catalase and the peroxidases rely on heme. Myoglobin, which is in our muscles, particularly the cardiac and skeletal muscles, contain a heme group, so they'll be weakened. And nitric oxide synthase is heme dependent. And without going into detail, in the various different synthases we have, in the urea cycle, it's essential that nitric oxide synthase is working because it catalyzes the biosynthesis of nitric oxide, and disrupted heme synthesis makes it harder to process ammonia. So you may get a buildup of ammonia and peroxynitrite, which you'll know is a very harmful radical. And for the geeks among you, cystathionine beta synthase, which is on a chart that we'll see in a moment, is heme dependent too. And that's the first step in removing homocysteine. So you can get hyperhomocystemia as a result of this entire chain of difficulties as well. So that explains it. I won't dwell on that page there, though it's interesting that this particular enzyme is also B6 dependent. Again, you've got this vicious cycle beginning. This is a wonderful chart of Dr. Amy Yasko's. It's actually on her home page. And you can see here that heme, for example, is central in the nitric oxide synthase step of the urea cycle. And it's here in the methylation cycle, particularly B12 being a tetrapyrrole can't actually be synthesized without aminolevulinic acid, which again is not going to be synthesized without B6. So you've got a very nasty vicious cycle affecting your methylation as well. And you've got heme here, the one I've just talked about, affecting homocysteine breaking down into cystathionine. And that will stop you producing sufficient levels of glutathione potentially. Look at that. That's the CBS cycle or pathway. So continuing on, the key deficiencies are B6 and zinc. And I'll just read this from that excellent article of Dr. Klinghart's and Scott Forsgren's. The KPU condition results in a significant loss of zinc, B6, biotin, manganese, arachidonic acid, which is omega-6, and other nutrients via the kidneys. So it can cause many knock-on effects, such as in the physical appearance, pale, sallow skin, and pale lips. That's due to the kind of anemia-like condition that's building. Light intolerance, that will be due to the lack of ATP, so that you're beginning to lose the ability to convert signals from outside into information in the brain via your eyes, potentially, which the brain just intelligently downregulates if it needs to, because there isn't enough ATP going around. Dark rings under the eyes, perhaps because of the huge work the kidneys are doing. If you think it through, you can work out with all of these why they might be happening. White spots on the nails, leukodynia, is because of lack of zinc. Impaired energy production, we've talked about, including anemia. Detoxification issues, we've also mentioned. Interesting is that MCS, that's multiple chemical sensitivity, can also arise as a result of these detoxification problems due to KPU. Though, of course, there can be many other issues contributing to that, and medication intolerance. The neurological issues are due to the fact that B6 and zinc metabolism, when it's low, affects your production of serotonin and adrenaline and dopamine levels. And this is really where it began with schizophrenia, but it can also contribute to psychosis, ADHD. Dr. Klinghardt will always test children with, who are on the ASD autism spectrum, and will, as we saw earlier, find it in most of them, the majority. Animal experiments have also shown that injecting rats, cats, and guinea pigs with free pyrroles leads to severe neurological disorders, and the source for that is actually below. So you can see the potential crossover with pediatric, and it doesn't have to be pediatric, it can be adult as well, autoimmune neuropsychiatric syndrome. I won't sort of, go into that in great detail, but obviously you can see this feeding into that condition as well that we've talked about in other webinars in detail. Thyroid disorders because of the hypoxia. The thyroid knows not to work as hard if there isn't enough oxygen available, and the zinc deficiency. Immune disorders because the synthesis of proteins is B6 dependent. So that means you can't even form antibodies properly. And that's what antibodies are made from, is proteins. So you may find you have a degree of immune dysfunction in your patient. Musculoskeletal problems because of the myoglobin I mentioned earlier. And this can even be reflected in EDS, that's Ehlers-Danlos syndrome. And there is mention of this, you'll see if you look for sources. That's because hyperextension of the joints can be due to manganese deficiency, and osteocytes require zinc and B6 and manganese, as well as magnesium and vitamin D. And Dr. Trudy Scott, who's a great specialist in this field where it relates to psychiatric disorders particularly, she has a very nice questionnaire here, by the way. She mentions in this quotation how it can affect all types of collagen, and that's where zinc, B6, but also omega-6 and manganese are needed. So just relating to the gastrointestinal system briefly, because lactoperoxidase contains heme, you may find your patients have lactose intolerance. Zinc is also a cofactor in the conversion of fructose into glucose in the liver. So lack of that can cause fructose intolerance. And then, of course, you've been lacking zinc for quite some time in the stomach, in your hydrochloric acid. So that can cause protein maldigestion and so on. You can find so many different links. B6 is vital for secretory IgA as well, and the mucosal membrane, in other words, along the gastrointestinal tract. And where MCAS and histamine intolerance is concerned, diamine oxidase, which breaks down histamine, requires B6 and zinc. So if those are low because of what you're going through, then you may well find that your histamine bothers you much more than it should. I mean, it's a natural production of the cells, but it should be broken down very quickly. And if your DAO is unable to do that, then you'll have excess histamine and even what gets called MCAS, mast cell activation syndrome. Finally, I think this is the last page of symptoms. It can even contribute to blood sugar disorders, and that's because gluconeogenesis is B6 dependent, and the conversion of protein and carbohydrate stores into glucose does require B6. Fascinating here in this article is the fact that the disruption of the nitric oxide synthesis in the urea cycle can actually explain high blood pressure, and it requires a bit more explanation to understand that. It's beautifully explained in this article, but here we have a new research focus on that particular aspect, which can be caused by other things. The breakdown in the urea cycle doesn't have to be caused by KPU, of course, but isn't it fascinating that that could be the explanation for high blood pressure? So you have a few points leading to metabolic syndrome here, like the fact that if the mitochondria are not functioning optimally, cholesterol isn't going to be broken down into its downstream steroids like estrogen and testosterone and so on. That's because cholesterol needs to be cleaved in the inner mitochondrial membrane, something that's not well known. But if that doesn't happen, then you'll get a buildup in the serum of cholesterol and of LDL. So high cholesterol and LDL in the serum, which you may well see in LDL as one of the blood markers that's off, can be due to that aspect of what we're talking about. And it has been found in diabetes. They have exhibited high pyrrole adducts as well. That's also referenced in number 3 down there, reference 3. I won't go into the fertility and reproduction issues in great detail here, but there's a lot about that in the German primarily, but also some English references. And that's because reproduction relies upon zinc and B6. So does the quality of eggs and sperm. And fertility relies on good methylation, MTHFR genes. If they're broken a bit, or at least not working as well as they should, because of what we saw earlier, that can affect fertility and also lead to miscarriage, unfortunately. So testing can be done using urine, and you have to be swift with this because these pyrroles, the mauve factor, are very light and oxygen and temperature sensitive. So AONM, which is now doing this test, and we're very pleased to have an excellent laboratory called Kiveno. It's an offshoot of Immune Diagnostics, which is a very big, well-respected laboratory in Germany. They suggest doing it from the first morning urine, but beware that if you have a patient who is suffering from circadian reversal and they sleep during the day and only get up late in the day, which is often the case in serious CFSME, then please take the sample when they get up, even if it is late in the day, and simply contact AONM and ask us about how to arrange the courier in those cases. The sample can be frozen and it needs to be put in the fridge immediately, and ideally should be taken in as dark a room as you can, because any light will begin to degrade these very, very sensitive mauve pyrroles. So that's a very reasonably priced test, which does, however, need to be sent immediately to Germany, to the good lab there. We've been told to not batch the samples and send them when there are enough. That can lead to problems of its own. It's good to analyze them as soon as possible. So that's a simple urine collection. And Dr. Klinghardt actually suggests coming off these supplements if you have been attempting to replace your Bs and with B6 particularly, and zinc and manganese. He suggests coming off them 5 days before doing the test. It's a long report, 7 pages. Here you can see a positive result. Anything over 150 is positive, nanograms per milliliter. And so this was really a very positive result. And the report goes on and does give some further explanation. Because mitochondrial dysfunction is such a large part of this puzzle, it could be worth considering mitochondrial testing as well, and perhaps simply, sending them all off at the same time. I won't go into that. We have got webinars about this, extremely good mitochondrial tests, again done in Germany. This would be part of an 11-page report, and I won't go into what all of these mean, but it can really give an indication of what's going on and why. You can see here that lack of B6 in this particular case would lead to severe problems in the tryptophan kynurenine pathway. And the mother here from the Epilepsy Foundation says, with B6 and zinc supplementation, my son's been seizure-free now for 3 months, and all of the behaviors have disappeared. I mean, that's an ideal situation if with, I say just, I'm sure they were doing other things as well, but with the supplementation of those missing nutrients, no doubt supraphysiological supplementation, she's been able to, her son has overcome his epilepsy. That's a fantastic result. But what I'm saying here is that it can be worth considering testing the various different nutrients to see if they really show up low on a test. We're talking here again about B6, zinc and manganese primarily, but tests don't show up intracellular and intramitochondrial levels reliably. So you may wish to rely on other types of testing for that, or simply go with the KPU result that you have. And there are actually specific therapeutic approaches where these kinds of nutrients are combined, because you do need to compensate for the macro and micronutrient deficiencies. But please do also beware that if zinc has been lacking for a long time, then the body will have utilized other bivalent metals instead in the places where it would have needed zinc. And so those are cadmium, lead, aluminium, and mercury primarily. So what will happen is you'll get a heavy metal detox once you start supplementing, if you're supplementing efficiently and the body is able to take up that zinc. So I'll talk about that a little bit more in a moment, but you'll need to consider detox and binders in your patient. And bioavailable copper may well play a major role. I'll talk about that in a couple of slides' time. And if it's a mitochondrial dysfunction, it's a good idea to find out what the issue is and remedy that, perhaps in parallel. So foods can obviously help, and knowing what foods contain high levels of B6, zinc, and manganese, but it will be hard to reach supraphysiological doses with food. And especially in a patient that may well be intolerant of certain foods or having, sensitivity reactions to them. So Dr. Klinghardt's remedy for KPU, and which he's, formulated himself and had for a long time, is called CORE, C-O-R-E. And it's just got key in front of it because of KI Science, Key Science, selling it at a formulary here in the UK, so that's nice and easy to get hold of. It does contain a lot of the nutrients we've just been discussing, and interestingly, he does have one called Core S. That's Core -S, S standing for Sine, and that means it's without one nutrient, and that is manganese. And that's if you have a Lyme patient, because Borrelia, the causative agent of Lyme, uses manganese rather than iron as a fuel, you don't really want to be feeding the Borrelia with manganese. So he suggests using core S for the first 3 months, and then obviously not starving the patient long term, then going on to core. And a company that AONM has long been, a great friend of. We actually introduced the Tiso Naturprodukter remedies to the UK, and they're now sold at the Natural Dispensary. They have always specialized in the mitochondria and in KPU. And it's actually due to a close affiliate of theirs. Well, I won't say affiliate, but somebody who works closely with them, gives lectures for them and so on, called Kyra Hoffmann. She's now actually Kyra Kaufmann, and her partner, Sasha Kaufmann. They've written many of the books that I've been referring to because they've written excellent literature in German and do actually produce, as well as having formulated this product here, they do also have infusions used specifically for KPU in Germany. So any of the doctors here who are able to give infusions, please do perhaps get in touch with us, because we can put you in touch with them and you can maybe bring over those KPU infusions because they don't exist here. So this is a good supplement as well that contains all those likely to be missing nutrients. Just to mention, and I won't have time for a lot more, I know, because it's close to 40 minutes already, but ferrochelatase is mentioned in that German literature as being the most likely enzyme to have broken down of the 4 inside the mitochondria. And it is copper dependent. So I've been told actually that all 4 of the enzymes are copper dependent. I haven't been able to dig into the literature yet and find out whether that's true, but it's certainly true of ferrochelatase. And so this is literature that backs that up. And here I need to say that I'm also very grateful to Morley Robbins and the Root Cause Protocol, which I've been studying for over 2 years now, because the Root Cause Protocol does put so much emphasis on the body's need for bioavailable copper. And this is something that I haven't found in the literature on KPU much at all yet. But I think this could be very central, because if it's bioavailable copper that your cells are lacking, then that could be the key to resolving their inability to absorb or properly metabolize zinc and B6 and manganese. And maybe you don't need to take that for the rest of your life, which is what's often said, that you'll need to take these nutrients in supraphysiological doses for the rest of your life. Well, if we can find the root cause, then perhaps that won't be necessary. So that is a longer story, though fascinating too that copper is so vital for the production of erythrocytes, which I'm sure you know, erythropoiesis and hematopoiesis. But again, it's this whole process is going to fall apart if we don't have the right type of bioavailable copper, and that's not every type of copper. So that would be a longer explanation that perhaps we'll go into in the sort of part 2 of this, but it's not a straight replacement. You need to ensure that you have sufficient ceruloplasmin, each molecule of which carries 4 of bioavailable copper into the cell. And ceruloplasmin is actually responsible for 95% of copper transport in the blood, barely ever measured, interestingly, in UK bloods. And, I've almost never seen that on NHS blood counts. And that in turn requires retinol, which is vitamin A is not simply beta carotene, and beta carotene being the cofactor, being the precursor to vitamin A, retinol, is often actually not properly metabolized. You'll see, again, if you do gene tests with your patients, you'll find that they often have a SNP in the conversion of beta carotene to retinol and won't be able to convert it properly. So there's quite a sort of ladder up to getting that bioavailable copper in the cells, and a lot in our current toxic environment, unfortunately, that's preventing us from being able to access it, including the fields, current agriculture that's simply very, very poor in copper. So if zinc does begin to displace the heavy metals, then please remember to use a binder like chlorella or zeolite. One of the advantages of chlorella vulgaris is that it's also been found to be a very good agent for spike clearance. So if part of your problem is a patient who has long COVID too and wants to recover their energy and get over the viral remnants that they may still have, then chlorella is a really good choice. Exercise, of course, will help to remind the mitochondria that you need them, but very gentle exercise, and in some patients it's inappropriate. The graded exercise therapy that's recommended for ME patients is often absolutely the wrong way to go initially. Infrared sauna can help for reasons we'll maybe discuss next time. A good electrolyte solution to replace all the missing trace minerals, support the liver with good nutrients, and don't forget a digestive enzyme, because the hydrochloric acid has been lacking for so long, and you want to really support digestion. It's all very well giving good nutrients and even good supplements, but if they're not being broken down properly, it's for the birds, isn't it? And GI restoration for the reasons we've already explained, like the low secretory IgA and the food intolerances and sensitivities that may be there as a result. So just a couple of pages that I won't go through on the support for the liver that may well be very useful for phase 1, all the nutrients, which is probably going to be very hard for a suffering patient to actually put together into a meal for themselves. So, a lovely supplement that contains all of those will be probably the best way to go initially. And for phase 2 detoxification, these kinds of vegetables, eggs, if they can tolerate them, and so on. I think those lists might be helpful. You'll definitely get them in the slides. So the last thing I want to mention is just that AONM does have various articles about this. The last newsletter had an article about KPU, and the Health Hub, which is the name of our blog, has an article on the hidden link between KPU and mitochondrial disorders that may be worth looking at. And there's an article called Kryptopyrroluria, the elephant in the room, on our website too. So I'll just finish up there and say that we will talk more about the therapy soon, if you'd like to. And thanks very, very much for being there. These are the contact details if you're interested in following up on this. I'll stop sharing now in order to have a look at the questions that have come in. So bear with me, please, while I just scroll up to the top and have a look at what has come in. Paul has said nitric oxide limits the constrictor capacity of endothelin-1, the most powerful vasoconstrictor in the body. This imbalance caused by cryptopyrroluria would dramatically affect blood pressure. Thank you very much, Paul. That's Paul Harvey. That's a fantastic tip. And I will read that article that I referenced, looking particularly for endothelin-1. They may not even have picked up on that yet. B2, he says, would also be an important cofactor for the body to be able to produce B6. Yes, absolutely right. One should really generally not give B vitamins alone, just individual ones. Jess mentions that SpectraCell micronutrient analysis will give you intracellular levels, but Jess, we've been unable to get that to America from the UK within 24 hours for a long time now. It's very, very hard. The couriers just don't seem to be able to manage it, and it must apparently be one day. Janine says, I wonder if this is therefore linked to POTS, as I believe this can be linked to endothelin. So I'll have to myself look up that connection, but thank you very much. Maybe I can get back to you on that next time. The heavy metal lead inhibits the last enzymatic step in the heme pathway. Yes, absolutely. You'll have an interplay of different factors here, not just one. On that Amy Yasko chart, there were lots of pathways that were blocked by different heavy metals, and that can be a real problem. HPU by Epigenar is a good HPU remedy, as mentioned by Marina. Yes, absolutely true. Jess mentions the BCOM or BCO1 gene. Maybe, Jess, you can tell us a little bit more about that another time. I don't know enough about that particular gene. Sebastian, you've asked, how and why do you get KPU other than possible genetics? Well, I know you joined a bit late, so possibly you missed that, or I didn't explain it fully enough, but it can be due to so many factors, like that, you know, even mitochondrial dysfunction, which we've talked about in later parts of the talk, can be due to many different things. It can be lack of specific nutrients. It can be due to specific pathways being blocked. It can be due to genetic issues. You have said other than possible genetics, so I get that. But there's a huge number of different issues that can cause mitochondrial dysfunction, which in turn can prevent you from being able to create your heme, which can feed into this. So let's cover that a bit more next time. I'll just scroll down a bit further. Yes, Jess has mentioned a particular NAC that is great for denaturing the spike protein as well. If that's part of the problem, then yes. And nicotine patches, there's a lot of evidence of that. In fact, the AONM newsletter about 4 issues ago, the cover article was all about that, in fact, about how nicotine, the nicotine receptors can be linked to that particular issue with long COVID. How would you marry Morley Robbins protocol with KPU support? Yeah, we'll talk about that perhaps next time, and I may need to bring in Morley Robbins himself. That's a fascinating point, Suzanne. Thank you. I'll just go now to the Q&A because I don't want to just focus on all of the comments that have come in the chat and miss that out. Mr. Smith, thank you for your comment there, because that's quite specific to a particular patient's condition. I'd like to suggest that we kind of bracket that one out for now, and we'll get back to you on that separately. Will the slides be available afterwards? Yes, I confirm that they will be. They'll be put under view past webinars together with the recording. It'll take a few days until they're up. Scott mentions that Dr. Klinghardt uses porphyrin testing for heavy metal toxicity evaluation. How do we know when high porphyrins indicate heavy metal toxicity versus porphyria? Scott, I must admit I haven't gone into porphyria as much as I would like to. I think that would probably need to be a separate talk. We could perhaps even have you talking about that. It is clearly very, very linked, because you need aminolevulinic acid. In fact, it's the delta aminolevulinic acid synthase at the top of that pathway in order to produce the different enzymes that go into producing the porphyrin that is being held together by these pyrroles. And if you're lacking any one of them, like uroporphyrinogen or whatever, then you're going to have a problem. And that each of those links to a different heavy metal, or can link to aluminium rather than mercury. So you're absolutely right. A fascinating topic, but I can't say that I've gone into that in sufficient detail to be able to answer your question. Afifa says, Ray, the SARS-CoV-2 situation discussed, might the binding of the spike protein to heme be responsible for the poor oxygen saturation we saw in many of those succumbing to the disease? I mean, it's difficult for me to say definitively yes, but it does look like that could be the case in some of the patients. I don't know how many, what proportion. I saw two people unable to get their O2 saturation up. One was down to 75% and he was hospitalized for a long time. Another couldn't bring it up from 82%. Yeah, I think we'd need a separate presentation on that. I know that Anthony Haynes, who may be here today, he is doing a set of 6 talks on long COVID soon, and will no doubt be covering that as well. So look out for that, Afifa and everybody else. I'll definitely be watching out for that set of webinars of his too. I'm just looking to see whether it goes down any further. It does. What we'll need to do is save some of these questions for next time, and I promise you we will, copy them all over so we have them. Do you feel that KPU is underdiagnosed? Yes, absolutely, especially here in the UK and in countries where there's not enough literature and not enough information on it. Would there be benefit from more routine testing? I would say yes, absolutely. We've been doing a lot of testing recently with this lab, obviously testing it out, trialing, and we have obviously sent in samples from patients where we suspected KPU. So there's a little bit of a bias there, patients who have been queuing up waiting to do the test, and certainly more have come back positive than negative. Did you say that B12 is a tetrapyrrole? Yes, it is. And that means because aminolevulinic acid is the sort of universal molecule that starts up the formation of tetrapyrroles. If that can't be formed for something so simple as you don't have enough B6 available, then you won't be able to synthesize B12. Would activating the NRF1 pathway, which creates and repairs mitochondria, reduce symptoms related to some of these issues? Thank you so much, Patricia, for that question. I'd love to talk to you separately about that. I'm not quite sure of an answer myself right now, but I think that Professor Brigitte Koenig said she would join as well. So maybe if she takes part in the next webinar with me when we go into these issues in a bit more detail, we could talk about that, because NRF1 as well as NRF2 are obviously very related to the mitochondria, as you say. Wondering whether testing for KPU drug-resistant epilepsy alongside mitochondrial function would be worthwhile. I think we could ask the lab about that. So that's an anonymous attendee, but do get back to us on info@aonm.org, and we'll ask the lab what they think about that. Another question here, would it be reasonable to make a diagnosis of KPU if one's patient makes significant improvements in anxiety and other things, if we provide them with high-dose B6 and zinc? Well, I almost think so, Afifa. Yes, might be a good idea to just sort of have documentation of that, but if testing is not possible, or for various reasons you don't want to go in for the test, then of course it would be a good idea. But just be careful, because sometimes high levels of B6 can cause neurological issues by all accounts. I mean, there are people who say, no, you don't have to stick to the 25 milligrams, it can be far higher. But in a patient who doesn't need it, where you're giving supraphysiological doses, over time that could be a problem. And as perhaps I'll talk about next time, nudged by Suzanne to mention more of the copper-related aspect to this, because zinc is an antagonist of copper. It can be problematic giving zinc in high doses long-term, because then you're suppressing copper. And so I'll go into the various aspects there that need to be considered. Another question here, could you please expand on the link hyperammonia KPU biofilms? Can we save that for next time, Inna, because that would probably require a little bit of extra, sort of background as well. I do know about the hyperammonia KPU aspect that I mentioned, but the biofilms is something I'd need to perhaps even pull in Dr. Schwarzbach for. Thank you. is there a bioavailable copper supplement that you can buy in the UK? Yes, there is one called Recuperate, with a sort of capital CU in the middle, that has been developed very reluctantly, actually, by the root cause protocol group, who didn't contribute to the formulation of a copper supplement for about a decade, because they thought, well, surely with good food, you know, nutrients, and removing what suppresses copper and ceruloplasmin, you can get people's copper up, but it just wasn't happening. So that group over in the States developed what's called Recuperate, which Your Health Basket now sells. And Your Health Basket has actually been a bit of a sort of secret supplier of rather wonderful supplements from that particular perspective. So I haven't seen it available anywhere else. Scott says, how often do you see full resolution of KPU versus a lifelong need for supplementing the nutrients discussed? Well, Scott, because you've written so many fantastic articles, I saw another one of yours that you wrote in 2022 that incorporated KPU as step 8 of your program. Perhaps we could really have you on telling us a bit more about your experience as well, because since AONM has only recently begun doing this testing, I can't say that we have a full cohort of sort of, you know, statistics yet that we can present. But certainly when I did the testing with Biolab in the past, when they did the test, did definitely see that it was very useful. But at that time, I didn't know quite so much about the underlying causes of perhaps needing so much zinc and B6 and manganese. So I'm looking forward to exploring that and seeing whether that can help us, rather than, as you say, needing to supplement the nutrients lifelong. Again, we'll know better after a while what percentage of people testing for KPU at our lab are positive. I would say so far it's been about 75%, but that's because we've had this slightly skewed cohort of patients who've been queuing up waiting to do it, where whether autistic children or whatever, from partly our work with Dr. Klinghardt, we very much suspected did have it. So I think I'll probably need to stop in just a couple of minutes, but we will save over the questions for later. How transient is secondary KPU? Well, that's an interesting question, and we'd probably need more scientific literature, more studies on this to really be able to answer that. Because of the, you know, paucity of literature on this, there isn't, you know, that there haven't been enough studies done. But what happens is that if a person has a tendency towards it, any kind of stress can really accentuate it. And actually, strangely enough, quite a few of the testing laboratories around the world do say, try to do the test when you or your child or your patient is going through stress, because they're much more likely to actually see the pyrroles coming out then than if you do it when they're, you know, more homeostatic. So I'll save the rest of the questions for next time. And thank you very, very much again for being there, for listening, for taking it all in, and for contributing those fantastic questions. I will just mention that we do have a couple of further events coming up, and I need to just quickly look at our AONM.org events section, where please do go yourselves to register for them if you'd like to before the e-blasts come out. But the upcoming event next is one on the 5th of September with Professor Gilbert and colleagues talking about another aspect of her book, which has just come out, called Borrelia Protocols. And these are colleagues who've written one chapter of that book and have huge expertise. So that will be Borrelia related. And then we do have another talk, as I mentioned briefly, on the 22nd of October, where Professor Brigitte Koenig from our mitochondrial lab will be talking about the links between mitochondria and longevity, which are obviously very clear, but she'll be talking about her research and her testing related to longevity, as well as telomere length, which is another test that we actually already do offer. So, and we'll let you know about the date for sort of part 2 of this. So thank you very, very much indeed for being there. And this will be up on the website under past webinars within the next few days. Thanks a lot. Bye-bye.